Percentage yield. Chemists use stoichiometry to calculate the theoretical yield. The math gives you the theoretical yield. The amount that you actually get from doing the experiment or doing the reaction, that is called, appropriately enough, the actual yield. Stoichiometry gives you the theoretical yield. Actually doing the experiment or reaction gives you the actual yield. Percentage yield compares the amount of the product obtained by experiment to the actual yield with the amount determined by stoichiometry. So essentially what we can do is we can compare how much we actually got by how much we could have theoretically gotten based on the math and express that, the portion of a whole, and we like to see it as a percentage, so we would multiply it by 100, and that is called the percentage yield. So try this one out. You should be able to do this first part, no problem. This is just regular stoichiometry. In part B, we will try the percentage yield calculation. So go ahead, pause the video, and do part A. What you should have got is taking the 75 grams of nitrogen from this reaction. Again, make sure the equation's balanced. We take our 75 grams of nitrogen and we want to convert it into product of ammonia here, NH3. How much could we actually produce from this? We want to do it in grams, so we're going to take our mass of nitrogen. We're going to use our conversion factor to convert to moles of nitrogen. We are then going to use the molar ratio of 1 mole of nitrogen producing 2 moles of ammonia for our next conversion factor, so that we're talking about moles of ammonia now. Moles of nitrogen is gone, we're now in moles of ammonia. We then finally convert that to mass of ammonia using the molar mass of ammonia. That will allow for the cancellation of the moles of ammonia, and we will be finally in grams of ammonia. So the theoretical yield for this reaction, if we start off with 75 grams of nitrogen, theoretically we could convert that into 91.0 grams of ammonia. However, let's say we actually carry out this reaction and we only get 17.2 grams of ammonia. That's the actual amount that we obtained by the reaction. So how much did we, what is our percentage yield here? How did we do? So we can take our theoretical yield, the yield produced from the math, the stoichiometry, and we can compare it to our actual yield. So we got a portion of that 91. We want to express that portion as a percentage. Just like any other percentage calculation, you would take your portion of the whole, multiply by 100, and you would have your percentage. So our 17.2 of the 91.0 that we theoretically calculated that we could have got, multiplied by 100, and we turn out to have an 18.9% yield. Same type of question done slightly differently. So here we have a reaction, and what it's asking for, it's saying that normally when you carry out this reaction you get a 92.4% yield. So given a certain setup, this is the percent yield we can expect. We want to know how many grams of calcium oxide, so this particular product here, can we obtain if we started with 12.4 grams of calcium carbonate. So we're going to take our calcium carbonate and we want to know if we ran through the reaction, how much calcium oxide could we get, knowing that this reaction tends to happen with only a 92.4% yield. So again, we're going to need the actual yield, the theoretical yield. We have the percentage yield here. So they are asking for how many grams of calcium oxide can we obtain. So we're looking for the actual yield. We're given the theoretical yield. If we had the we're given the percentage yield. If we had the theoretical yield, we would just do our calculation and we'd solve for the actual yield. However, this is not product. This is calcium carbonate. We've got to convert it into product, and then we will have our theoretical yield. So pause the video here, take your 12.4 grams of calcium carbonate and turn it into grams of calcium oxide so we can find out what our actual yield would be using those numbers. So find the theoretical yield of the product first. This would be done by taking your 12.4 grams. We're using our first conversion factor here to get rid of our grams of calcium carbonate to be in moles of calcium carbonate. It then cancels out to be moles in calcium oxide. We then use the molar mass to cancel out the moles of calcium oxide. and you should have ended up with 6.95-ish grams of calcium oxide. Now remember, we got this through doing stoichiometry, so this is the theoretical yield. We know the percentage yield. Now we just need to calculate the actual yield. So we have this term, we have this term, we're solving for the actual yield. So essentially, we want to know what is 92.4% of 6.95 grams. Rearrange for actual yield, and you should end up with 6.42 grams as our actual yield of product.